This brings us to our final clever improvement to the AList class. How do we turn this horrible, I don't know why I said it that way, horrible parabola into this beautiful line? So if we look at this resize method here, that's our, this code right here, that's our problem. Something here is broken, and what I want you to do is try and consider how you might fix this. Now the solution to this problem is actually a bit tricky, and even after I show you, you might be a little mystified, and we'll cover the analysis later. But what we do is maybe give it a shot, maybe even try out the AList speed test to test your solution, and I'll spoil it in a moment. Okay. So let's actually go back to our speed testing environment. Now let's look at our AList class. This is our trouble. So perhaps you thought, what if I increase the amount by which we resize? Maybe by, I don't know, from 1 to 10. So if I recompile my code, and now I do speed test AList, I'll see it's fast. It's not as fast as the AList, but it's pretty fast. And while that seems to be a big improvement, there's actually something a little subtle here that's tricky. I mean, as subtle things often are. And that's if we increase our speed test AList runtime up to 1 million, and now we try running it again, it's quite slow. It should not be like this. In fact, it's taking quite a long time. So even though we increased this size up to 10, we were only kind of hiding the problem. There's still a big problem here. So there's actually a bigger, better solution, which is rather than adding 10, I'm going to multiply by some number. Let's say 2. So let's try now by multiplying the size of our array. If we try running it, it's quite fast. Look how fast it is. In fact, I can crank this thing up to 10 million. Try running it again. Should still be pretty fast. And that's actually the state-of-the-art approach. And real lists, like the list inside of Python, basically uses this multiplicative trick. So what we have right here, this add last approach, where we add some random factor or some scaling factor, R factor, this is unusably bad. The resizing factor, if used in an additive way, it's just not going to work. I mean, unless you cheat and you make R factor super big, but then that's cheating because then you just keep around a size billion list. I mean, of course that works. By contrast, if we actually use a multiplicative or geometric rescaling, then we get great performance. This is wonderful. This is how all kinds of lists out there are implemented, but we can't do the analysis yet. We're going to wait till after the midterm to go into detail. So for now, we'll treat it as some kind of wizard magic, that this is the right approach. Now there's still a little bit more we want to do, which is that occasionally we'll have an issue where our list gets super big. It goes up to 1 billion items, and then we remove 999 million items. So at that point, we're only using 1% of our available of our array, and that's wasteful, right? I mean, we could always make a list fast that uses an array by keeping a giant array, but that's just a waste of space. And so the question is, what do we actually want to do to make this better? I kind of spoiled that problem. Okay, that's fine. So what can we do to make it better? Well, often what we'll say is an array list has a usage ratio, you might call it, or a load factor. And that's simply the size of the array divided by the length of the size of the list divided by the length of the array that represents the list. And so often what you'll do is if that load factor, that usage ratio, falls below 25%, then you will half the array size. And we'll do some more details on this in a few weeks. So just as an example, let's say we have here an array it has length 100, but the list is only size 4. And so the usage ratio here is only 4%. That is well less than 25%. So this should have been resized at some point. And so this actually drives home a really important trade-off between time and space efficiency. We'll see this over and over again. We'll talk about things like hash tables and how we can exploit space to save time. And that'll be a big theme of this course. So with that, we have now built basically an array list. We'll have to do a little bit more tweaking, but that's the core idea, the most important stuff. And with this next little video, you'll be ready to finish Project 1A.